Danny, if you're ready, I think you're going to need to do the thing, which is to press the button that says share screen.
So, welcome. Uh, this is this week I've been writing this smart contract that I call NEARmons. It's a smart contract that basically creates NFTs, and these NFTs are essentially creatures with skills and attributes. You can think of it as Pokemon, actually, like fire move, water move, and then you can actually create new creatures by fusing two creatures, and then the descendant creature would inherit skills and attributes from the ancestors of your choice. And so this would be considered an in-game collectible that could be used one day in part as part of a trading card game. And so this is the project repository, and then let's see, Sharif, what should I show next?
So if you've given us an idea of the project, can you give us an idea of maybe how does it look like when you're using it? Do you have an interface of any sort, whether it's
Yes.
designed or implemented?
Um, let's
You're only
see.
1 minute in, by the way. So if you give us a sense of how it works, what it feels like when you're using it, and then we can dive into the code.
So there is no front end at the moment. I've only started on the contract itself. I wrote the tests, and I've deployed it onto the mainnet and called it and all that stuff. Um, so no front end, but I can show you from the interface. Um, let's see. What should I show first, actually? Um, so first we can call yarn test just to make sure everything works. Basically, I would say that this contract is a lot more complicated than what I wanted to, and there have been challenges along the way, like how much, like design problems, like what to store in and what to keep out, and I also had to consider the trade-offs between storage and speed. So let's see. Okay, all of them are passing, which is a good sign. So I'll walk through code actually. Let's go through models.ts. So there's the creature IDs list, creature and sample creature classes. Um, these are basically used, sample class is used to identify the creature itself, like as a sample, basically, not something owned in its original form. And the creature class is the one that's actually owned by the owner. And creature.id list is the list of creature IDs that are owned by an owner. So we would use those IDs for fast lookup times. And here we would call the init contract that would initiate all of the data structures that we need in order to um, um, find the creatures that we need. And then in index, we have roughly 200 lines of code where you can retrieve the creatures by owner. You can preview the future child creature by looking for its ancestors' instant IDs, and then you could actually fuse for the creature. And then you can actually give creatures to the owner, where essentially you start with nothing. So I decided to create this in order to give people creatures to start with. And so let's actually do some demos. So what I would do is...
And you're almost at 5 minutes, just for your own sense, maybe 2-3 more minutes max.
So I'm going to run the script that basically rebuilds the contract and deploys it. Okay, now it's deployed. Now we just have to export the contract is equal to this account. And we also have to do near login, of course. And I'm gonna put in mons testnet. Close window. We're here, export owner equal to mons.testnet. And so now we have both the owner and the contract ready. So let's run the second script. So we're gonna run this script. It's gonna initialize the contract and make sure all the data structure is ready. And then we also give ourselves creatures to start with. So you could see that we already have two creatures. Each of them has a sample ID and an instant ID. The instance ID is the very unique one, and the sample ID is the one that's specific to that creature. It's the same no matter who owns the creature. And you can see the attack, defense, and speed values, and then the skills and what element it is and what evolution rank it is. The higher the evolution rank, the more powerful it is, essentially. So let's actually start fusing. So let's go into.
So just another minute before you wrap up, please.
Yes. So we can actually preview the future child by. So if we take both of the instance IDs and just copy and just paste them in. Copy, paste. We will be scheduling a call that gives us an idea of what the future child would look like. Here, this would be the future child. And so now, if we want to actually create the child, we need to call the procreate function. And this would be like this. And then we copy over the instance IDs, where we go all the way to parent ID instance equal to A, and then R is copy, paste, and then the skills. Let's just say let's just leave it as B for simplicity's sake. So IS, and then let's import one of the ancestors. So we have FS. Let's put in FS, and then finally the new creature sample ID would be L1, and we call scheduling call, and now we have produced OSP, which is the name of the creature. And so now if we call this function, we should see that we have 3 creatures that we own now.
It looks like the command didn't run as expected. You might have to Control-C and then try it again.
Yes. Let's see. Oh yeah, I'm missing the. Okay, see, now we have, we owned 3 creatures. The 2 that we owned, that we were given at first, and then the last one, OSP, that we fused from these previous one. Now, now going by what I just did, you can continue fusing these creatures, and then basically they actually evolve. You can see here that the evolution rank is actually rank 1 because we fused 2 zeros, which means as we continue fusing, creatures will become more specialized and just more powerful in the future. And I wanted to implement trading, but that would have been way too advanced for me at this time. And yeah, that is all for my demo.
Okay, that's great. Congratulations. Spot on 10 minutes. Do you want to take maybe 30 seconds to talk about a few lessons learned or anything that caught your attention during the week?
Well,
And just to keep it brief, please.
yes. One really big thing that I learned is that sometimes I have to take a step back and while the take a step back and learn to read a book and read the book, get to know all the tools that are necessary, how to test basically, rather than going in dark. And sometimes the short term, while the short term time that you put in seems long, it would be probably it would be worth it in the long run.
Okay, thanks for that, Danny. Congrats. Great work. We're at 11 minutes.